All right, we're back. We're still on page 8. Are we on page 8? Yeah, we're on page 8. Sorry, I was looking at a weird thing where I added an extra page, so now there's 9 pages in my, I don't know, I'm on page 9 in my file, but page 8 of the notes. Doesn't really matter. All right, we're going to use polar to find the area of the region enclosed by x squared plus y squared equals 9. It's a circle that has a radius of 3. The answer is 9 pi. Like, that's not the thing, right? It's not about that. It's about, can we use polar to get this? So the first thing I need to do is I need to convert this. So I'm going to say, well, I mean, it's r equals 3, right? This is the polar curve. And then I know that to get the full thing, it takes 0 to 2 pi. Those two steps are essential. You have to know how long it takes. You have to have a sense of the polar curve. Like, I know that r equals 3 is just a circle. I know that I'm here at 0, I'm here at pi over 2. So I could go from 0 to pi over 2 and multiply by 4. I know that I'm here at pi, so I could go from 0 to pi and multiply by 2. You frequently want to do that because of the stupid 1/2 that's in front of the area integral that everyone always forgets. So it's just easier to do like half and double it and never deal with that. But let's see if we can do this. So the area should be 1/2 the integral from 0 to 2 pi of r squared, so 3 squared d theta. That's 9, so that's 9/2 theta from 0 to 2 pi, which is definitely 9 pi. Okay, so that's one option. Another option is we could have done 2 times 1/2 integral from 0 to pi of r squared. And then here we just get 9 theta from 0 to pi, which is 9 pi. I'm just like illustrating, like it's normal to think this way. And a lot of polar area questions, because they're like super annoying, will actually just be multiple choice and be like, which of these is equivalent to the area? I'm going to do this, but I could also go pi over 2 to pi, pi to 3 pi over 2, 3 pi over 2 to 2 pi. All of them are going to work. R squared d theta. So this is 9 times 2 is 18 theta. But from 0 to pi over 2, which is 18 over 2 is 9, 9 pi. We're getting 9 pi no matter what. We knew we were going to get 9 pi though. The key is like, can you do the polar stuff? It's not like, can you get this particular area? I will say, I once had a student who pretty much on multiple choice outright refused to do a polar integral because area is still area. And if you look at the multiple choice options, usually the answers vary by so much that if you just start like going with like rectangles or whatever, you can put a bound on the area, and usually on like the AP multiple choice, that's almost enough to get it. So never forget that. Like, it's better to be able to actually like set it up, evaluate it, whatever. Failing that, it's really good to be clever enough to realize like area is area. So like I should be able to do this, including like you can sometimes throw a circle around a polar curve and just be like, the area of the circle would be this, so the area of the polar curve should be like around this. All things to think about. Okay, this I recognize without being given this equation, which I do not want to convert. I know that this is r equals diameter cosine theta. Positive cosine because we're on the positive x-axis, diameter cosine theta. So I know that the polar curve is going to be r equals 6 cosine theta. And I know this type of polar curve, this is where it all comes in. This type of polar curve only takes 0 to pi to trace out. So if you're unsure about that, if you've been watching these videos, you know that I ate a stupid vanilla cream filled donut with powdered sugar, and it like, it really got me. I like breathed in the wrong way, and I'm suffering for it. But watch the math analysis videos, note 16. Go into the playlist, find polar circles, like polar coordinates of circles or something like that. And make sure you really understand it, because now it's really going to get us. So we could go from 0 to pi over 2, 0 to pi over 2, sorry, 0 to pi over 2 and double it. Not a bad idea. We can go straight up 0 to pi and get the answer. We can go from pi over 2 to pi and get the answer. It just depends on how you want to do it. So I'm going to go all the way. I'm going to go from 0 to pi. So area is going to be 1/2 the integral from 0 to pi of r squared. And then you have to integrate sine squared and cosine squared a ton when you're doing these. So this, so it's 36 over 2 is 18, and the integral from 0 to pi of cosine squared. So just to really quickly review what you would do there, where should I put these? I'll put them over here. Cosine squared of theta is 1 plus cosine of 2 theta over 2. And then sine squared, when it comes up, will be 1 minus cosine of 2 theta over 2. These are the power reducing formulas, and they're pretty important. They're pretty important because they let you change from sines and cosine squareds into just sines and into just cosine. And you can integrate that. That's the idea. Like, you want to be able to actually integrate. You can also, I'm pretty sure you can do integration by parts on cosine squared if you want. I don't know why you'd want to, but I think that'll work. So I'm going to replace it. I'm going to take out the 1/2. 0 to pi, 1 plus cosine of 2 theta d theta. So that's 9. And then it's theta plus 1/2 sine of 2 theta. So it actually, you end up with sine a lot because you're almost always integrating cosine. And also you frequently just get 0 for that part. Like, you're almost always like on the x-axis where sine is 0. So that's just a nice little bonus that sometimes will happen. Also, it won't always happen. But this is 9. I get pi. The sine of 2 pi is 0, so that's gone. And then minus 0, so I get 9 pi. Now, does 9 pi make sense? Of course it makes sense, because this is a circle with a radius of 3, right? And so the area is going to be 9 pi. It's just a question of, like, how are you going to get it? So I decided to go all the way from 0 to pi. You could have gone from 0 to pi over 2 and doubled it. You could have gone from pi over 2 to pi and doubled it. You can't go from 0 to pi over 4 and multiply by 4. That will not work. The reason that won't work, so this is like not really mandatory, but when you get to pi over 4, you're here. And when you get there, you've only done, well, not only, you have traced out this super weird sector-y deal. This would be if you went from 0 to pi over 4. Going to 0 to pi over 4 and then multiplying by 4 does not work. You have to understand the shape, the way that it's graphed. There's like a lot that goes on with these. So, like, do the obvious things, but don't try to get too clever, because if you get a little too clever, you might run into a problem. So don't do the 0 to pi over 4 thing. Up here, you can do almost anything you want because the symmetry is like perfect. The way it traces out is like perfect. Down here, not nearly as perfect. All right, I'll be back in the next video. We're just gonna do polar area for days here. And you can see, like, is this a polar region? No, this is not a region you would choose to describe in polar, but we're gonna describe it in polar, and then we're going to evaluate it to see if we understand what we're doing. So I will be back in the next video and we'll do some of those, and I will see you there.